10.3 notes, polar coordinates, pages 1 and 2. There's not much on 1 to do. Some vocabulary we definitely want to talk about. We'll get a little more involved with everything on page 2. So for a while, for years actually, you've been plotting rectangular coordinates, the Cartesian coordinate system. And so let's take a look at what we've got here. Example 1a, we want to plot these 2 points, 2, -3. So point A is 2, -3. And so we know that we go 2 to the right, 3 down, and here's our point A. We get that by going 2 over, 3 down. B, -4, -1, we're going to head to the left, 1, 2, 3, 4, down 1, and here is B, -4, -1. So think back to when we were taking a look at the unit circle. We actually have a different way that we can plot things on the plane, and that's using the polar coordinate system. So let's take a look at point A here. Just like we did with vectors or with the unit circle, we could find the length of that from 0, and then we could also find the angle that is made with the x-axis. And we can either go the negative direction, we can go the positive direction. We know there are multiple ways to get there. And so that's what we're going to take a look at here when we talk about the polar coordinate system. So the polar coordinate system, still an ordered pair. This time it is an r theta. So r is the same way that you have been using it. It's the distance from 0. Here we're calling our 0, the origin, the pole. Okay? And then we're going to rotate some theta. So the polar axis lines up with our positive x-axis. Our rotated axis is where theta moves that axis to. Okay? Angles work the same way they did before. It's positive going counterclockwise. It's negative going clockwise. And then the positive or negative r are going to work the way we think about them too. If we're plotting along the rotated axis from our pole, that's our positive r. If we're going in the opposite direction, that's the negative r. So there's page 1 done. Let's take a look at page 2. Let's see if we can color coordinate these so we don't get confused. So point A is the point 4 to 70. And so you'll notice our polar coordinate has our angles marked off, and then it's got these rings. These rings are our r's, our distance away from the origin. So for A, I'm going to start with the angle. My angle is 270 degrees. So if this is my polar axis right here, let's 90 is straight up at pi over 2, 180 is pi, 3 pi over 2 is 270 degrees, so I know that I'm going to be somewhere along this one. My r is 4, so from the center I'm counting out 1, 2, 3, 4, and here's point A. B is -5, 5 pi over 3. I'm going to work the same way. I am going to start with the angle. So my 5 pi over 3, there is my rotated axis. This time though, my r is negative. So instead of going along that in the positive direction, I'm going back this way in the negative direction. Negative, here's 1, 2, 3, 4, -5 right here. C is at 3, -120 degrees. 120 degrees is positive 2 pi over 3. So negative 120 is going to be negative 2 pi over 3, or down here at 4 pi over 3. And we're moving in the positive direction, so along that rotated axis. 1, 2, 3. Here's point C. D, negative 3 pi over 4. So negative 3 pi over 4 heads down this way. It's the same as 5 pi over 4. So there's our rotated axis this way. We want to go negative 3, and so we're going to head back. 1, 2, 3, and there is our point D. Last one, E here. We're going to plot 3 pi over 4. So we're going to start with that. My 3 pi over 4 is right along here. 4 out, so there's 1, 2, 3. There's my 4. We know we went this way to get to that 3 pi over 4. I could also go the other way. And so that angle would be negative 5 pi over 4. I'd still be moving in the positive direction along the rotated axis. So 4 and negative 5 pi over 4 puts me at the exact same point. I could go, let's see, now I've got a positive angle, a negative angle. I'm going to need a negative r. And so if I'm going negative 4, that means my angle has got to be right along here. So positive 7 pi over 4. Negative 4 puts me at the same place. And how else can I get there? Negative 4, negative pi over 4. So let's see if we can take a look at this. We've got positive r in two places with a negative and a positive angle. We've got negative r in two places with a negative and a positive angle. Okay. So this is where that unit circle and knowing those angles is going to be incredibly helpful. Last thing we're going to talk about here, example 3, we want to convert between polar and rectangular. So we want to start by coming up with every way that we have to relate our rectangular coordinates and our polar coordinates. So first off, I'm going to draw in my right triangle. That's how we've been looking at these. And if this is the point xy, I can label these sides xy. I know that I'm going to call my hypotenuse r and this angle theta. So let's see what we remember. Sine of theta, we can do that, is y over r. We've got the cosine of theta, x over r. While we're at it, let's throw in tangent. That one's y over x. And then from there, I can solve for parts of these. So let's start with this one here. X is going to be r times the cosine of theta. I can take this one and solve for y. I get y equals r times the sine of theta. I can also use the fact that I know that x squared plus y squared equals r squared. Which means that r could be equal to plus or minus the square root of x squared plus y squared. So let's see, we got x, we got y, we got r. You know what? We need theta as well, so I'm going to use this one. Theta equals inverse tangent of y over x. I think that is all of the possible ways that I can come up with that demonstrates the relationship between our rectangular coordinates, our x and our y, and our polar coordinates, our r and our theta. So let's see what we got here. If we've got something in polar form and we want to convert it to rectangular form, I am going to find, I can plug in the r and the theta to find x. I can plug in the r and the theta to find y. And we may use that x squared plus y squared equals r squared. We'll leave that. If we have them in rectangular form, we want to convert to polar form. I'm going to use this r squared equals x squared plus y squared, or r equals positive or negative square root of x squared plus y squared, kind of depends on where we are. And theta equals inverse tangent of y over x. So keep in mind, any of these pieces above, I may find a place where I need to plug in y over r for sine theta or x over r for cosine theta. It's going to kind of vary based on the situation we're given, and we'll see that as we move forward.